Hi, today my name is Amanda Pennington and we are going to be talking about Module 2 lesson. So let's go ahead and get started. Here we go. No, here we go. So today we're going to be talking again about Module 2 lesson, and it's going to be Chapter 9, Geometry Figures. So here we go. Okay, so first off, I wanted to go over what supplementary angle, complementary angles, and similar angles are. So what is a supplementary angle? That is when either two angles add up to 180 degrees. That means that there's this line right here, and then there's two angles, that these two angles have to add up to 180. So we know from looking at this that 120 plus 60 equals 180 degrees. And so that's how we can verify that we got the right measurement. Okay, what is a complementary angle? When either of two angles add up to 90 degrees. That means at a 90-degree angle, which is right here, that since there's two different angles, those numbers have to add up together to get 90 degrees. So 35 plus 55 we know is going to be 80 plus the 10 will give us 90 degrees. And so we're going to have to be aware of those. Also, what are similar angles? If two triangles have corresponding angles are congruent and corresponding sides are proportional, that means the same shape but not always the same size. So we know that these two triangles look absolutely alike. One's just smaller than the other. So these sides will be congruent. Okay, so here's our first question. Chapter 9, number 5, question 1. Demonstrate the relationship between angle 1 and 12 chart are similar complementary and supplementary angles. So what we're going to do is we're going to figure out and kind of explain how we got our angles. And then we are going to show you specifically what similar complementary and supplementary angles are. So we're going to add in vertical angles so you can understand and see those together. So at the beginning, we have the 61 and 63 degrees in white right here. When we add those together, that has to add up to 56 degrees or 180 degrees. So we're going to be looking at those, and we're going to be looking at the supplementary and complementary angles. So we're going to go ahead and get started. Just so you know, everything that you see right here in this diagram is going to be on the next slide. So we're going to take everything we have from there. So here's our line 1 and our degrees. We know that this is the top portion of the diagram that just went on. So we know that we have to add 56 plus 63 plus 61 and together to get 180 because they're supplementary angles. Because that line 1, which is right here, is going to be that line and everything in it has to be that 180. So that's how we can tell that we got everything that we need. So that is just an example of a supplementary angle. Next, we're going to add the two parallel lines that we had from the first diagram. Now we're going to have 7, 8, 11, and 12 angles. Okay, so when we had solved for the triangle, we're going to say that angle 7 was 56 degrees. But right here, that 7 and 8, right here on this line, that becomes a supplementary angle. So we know that we are going to have to minus that 180 minus the 56 to find out what angle 8 is. And we will do that. But look right here, 7 and 12, they are called vertical angles, which means that they're on the opposite side of each other, meaning that they're going to be the same degree amount. So when we solved for angle 8, which was 124, we got this. So we know that 7 is the opposite of 12 because of the vertex that they're sharing. So these are going to be 56. and 8 and 11 are going to share the same thing, the same vertex on the opposite sides, which are going to give them the same measurement, which is 124. So that's just how you can tell that those angles are like that. And not all the time you will see this. Most of the time when you see this, they will be vertical angles, and you can find the measurements easy to do by that way. Next, we're going to have our parallel lines again from the first diagram. Okay, and here's that 61 plus 63. And so we're going to search for what is this angle. Well, we minus the 124 that we got from adding 61 and 63 together from 180, which gave us the 56 degrees. And every triangle has to add up to 180. So we're going to add our parallel lines again. Now we got angle 1, 5, 7, and we know the angles 1, 5, and 7 are going to be congruent, which means they're going to hold the same degree measurement amount. So that means that 56 is going to be the measurement for angle 1, 5, and 7. And so that's an easy way to understand that, because they're going to be on the opposite lines. They're going to cross this vertex, and then they're going to cross this line right here. And that's how we know that they're going to be congruent. Next is to show similar and complementary supplementary angles. So here we have our triangle, and it's a big one. We got two small triangles in there, and then looky here. We're going to look closer at this. So we know that given we have 74 degrees for angle C and 26 degrees for angle B. Now, since this is a big triangle, to find, and that has to add up to 180, we're going to find angle A. Okay, and so we know from this first box right here that adding 74 plus 26 equals 100. So since we need to look for added up to be 180, we're going to minus that. So 180 minus 100 equals 80 degrees for angle A, or angle 1, because they're going to be the same thing. But then we also see this. We know the supplementary angles are going to, for angle 1, are 3, 5, and what else? 8. So we can go ahead and plug those in, because those are going to be our congruent angles, not supplementary, not that, but congruent angles to 1. So we need to know then, we got measurements now for this right here. So 74 degrees plus 80 degrees, we need to know what that is. And so when we add those two together, we're going to get our answer. And same thing here, we're going to add our 80 and 26 to get our angle 6, or 26 and get our angle 6. So we did that, and angle 80 plus angle B is 106 from this box right here. So 180 minus 106 equals our 74 degrees. And then we're going to look at angle 4. We know that 80 plus 74, just like before, we have down here. So when we add those together and minus from 180, we get 26 degrees. Now we have our supplementary angles, which is right here. These are supplementary. That means 26 plus 80 plus 74 will equal 180 degrees, just like a triangle. Now, one thing that we are going to look at now is going to be right here. We know that 7 and 8 are also supplementary angles. So that means that 80 degrees minus the 180 gives us 100. That means angle 7 is 100, because 100 plus 80 equals 180 for the supplementary. And that's going to be the same thing right here, angles 2 and 3. They're going to have to be 180. So just like before with angle 8 and 3, they're 80 degrees. So 180 minus 80 equals 100. So, but we can put this little line through it, and that can make 2 more triangles. And when we make 2 more triangles, we know each triangle has to be 180. So when we take our 2, there's going to be 180 measurements in each one. So that's how we know we got the right answer. Next, we're going to demonstrate how to find the measures of the angles in the concave polygon. And so one of the first things we need to do is we're going to add our sides together. We're going to add them up together. So here's 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 sides. So we're going to use our first formula in step 1. So our formula is parentheses n minus 2 parentheses times 180. That n is going to represent the number of sides we counted, which is 8. So we're going to plug that in. 8 minus 2 times 180, that's going to equal the 1080 degrees, 1080 degrees. And we're going to hold on to that number. Next, we're going to do step 2. Now, for this problem, we're going to have to add up all these angle numbers with the value with y. So 3y plus 7y plus 7y plus 7y plus 3y plus 12y plus 12y and plus 3y. We're going to add those all up together in the box of step 2, which shows that it equals 54y. Now, we're going to take that 54y and we're going to take the previous number of degrees from step 1, that 10 or that 1080 degrees, and we're going to make an equation. So 54y equals 1080. Then we're going to solve for y. In doing that, we've got to get y by itself. So we're going to divide our sides by 54. And 1080 divided by 54 will give us 20. So y equals 20. Now that we know what y will be, we're going to move to step 3, which is going to be this orange box. And we're going to take the 3y right here. Okay, and we're going to plug in our 20 value for y, since we know what it is. So 3 times 20 is 60 degrees. So that means every y, or 3y, is going to be 60 degrees in measurement. Next, we're going to do the same thing for 7y. So we take our 7 times 20, and that gives us 140 degrees. That means every 7y is going to be 140 degrees. Next, we're going to take our 2 12y. So 12y, so we're going to do 12 times 20, and that gives us 240 degrees. So 240 degrees for each y, 12y. So that's just how we find all the measurements for this question. So we have solved that problem. Now let's move on to the next one. Find the angle measurements. Now you might think, how are we going to find those measurements? They don't give us no numbers, no angles, no nothing. How are we going to do that? Well, I'm going to tell you about it. This is how we're going to do it. To find the interior angle, exterior angle, and central angle, we have each equation. But just like the last problem, the number of sides of this shape is going to be so important. So we're going to count those. So we're going to start right here. 1, 2, 3, 4, 5, 6, 7, 8, and lastly 9. So we know that we have 9 sides, and that's very important for us to remember. So for the interior angles, which is going to be this pink box, we are going to use the formula that's in here. So n minus 2 in parentheses times 180, and then we're going to divide it by n. Now n is going to be the number of sides that we counted together. So we know that n equals 9, and we're going to plug that in. 9 minus 2 times 180 divided by the number of sides, which is 9. So we solve 9 minus 2, which is 7. So 7 times 180 divided by 9 equals 140. So the interior angle is going to be 140 degrees. Now the exterior angle, which is going to be in the blue box right here, this is going to be 360 divided by n. When we know n is 9, because that's our sign, so 360 divided by 9 equals our 40. Okay, and then we have our central line. Our central, or not line, angles, my bad, our central angles. So 360 divided by n will give us our answer for the central angle. So 360 divided by 9, which we did previously in exterior angles, we know is 40. So that is how we find the angle measurements that we were looking for, and we didn't have to have any kind of measurement in degrees or any kind of numbers. We already had all the information. We just needed to know the number of sides that we had. And that's how we solve that equation or problem. Let's go on to the next question. Here, we needed to create a tetrahedron inside of a cube. Now, we want the vertex, which is in blue, right here, this last part of the cube, the vertices of D, E, G, and H are part of the cube that is vertices of the tetrahedron. So we needed to put that in a different color. So what we need to do, though, the question wants us to make all the tetrahedron faces or planes not to be able to touch any of the cube faces or planes. So in doing that, we are having to make it where it doesn't touch any faces. So we're going to have to put a tetrahedron inside of a cube, which is already done in the figure. So we can see, you know, for EDB face right here, that's not touching any of the faces of the cube. And the same thing for here, B, D, and G face, that's not touching any of the planes of the face. And we know by this dotted line right here that this is going to be another, like the bottom of the tetrahedron. And we know the EBG face isn't touching any of the planes or faces of the cube. And that's how we know that we have got that right. So that is how we solved that problem right there. Let's move on to the next question. Okay, chapter 9, show legal, I believe I'm saying that right, diagrams for the tetrahedron, octahedron, and the isosahedron. So we're going to look at those. So first we're going to look at a tetrahedron. So this is what that looks like. And we know from the definition that just popped up in yellow color, it says four-plane triangle face. That means that we have four faces on this triangle. So we see that here's one right here, here's 2, and 3. But the bottom of that tetrahedron will be our fourth plane face. So we have that right. So that's how you draw or build one of those tetrahedrons. It's just a 3D four-sided triangle. Okay, next we got to make an octahedron. An octo will mean 8. So at the beginning we know that we have to have a triangle with 8 faces on it. So and it says especially a regular solid figure with 8 equal triangular faces. So we know that these have to all be triangle faces. So we're going to count those. This is 1, 2, 3, 4, 5, 6, 7. Well, where's that other one? It's at the bottom that we can't really see right now. So that's going to be our 8 face to that octahedron. So we got to remember though that each of those faces has to be a triangle. So let's move on and do an isosahedron. An isosahedron, that is a very uncommon thing for us to hear. So we're going to see what that is. It's a solid figure with 20 plane faces, especially equilateral triangular ones. So that means the same thing with the octahedron. All the faces have to be in a triangle shape. And this time there has to be 20 faces. And that's a whole lot. So we're going to count those together. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we're going to start in the middle. 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Well, there's 19 faces. Where's our other one? It's at the bottom again. So that will give us our 20 plane faces. So that is how you would draw each of these. So the thing to remember is that each face has to be in a triangle shape. And we can kind of know how many sides or faces we're going to have by the beginning of the words. So we're going to know that tetra means 4 plane triangular faces. octahedron is 8 plane faces, and isosahedron is 20 plane faces. And that is going to be the end of our presentation for Module 2 lesson for Chapter 9. I hope you enjoyed it. If you have any questions or anything like that, please make any comments, and I'll be glad to help you. Have a very, very good day. Thank you so, so much.